Good morning, everyone. I welcome you all to this lecture on Z transforms, where we will be solving few problems related to Z transforms, and we will be proceeding ahead with the inverse Z transform by partial fraction method. So these are the contents what we'll be covering in today's class. And let me move ahead with the first problem of today's class. Find the Z transform. Find the Z transform of the following sequences. Or signals. Okay, so following sequences or signals. Okay, so now in order to find Z transform, you know that X of Z, I keep on repeating it. So it can also be written as Z transform of X of N. It can be written as sigma N equals minus infinity to plus infinity X of N Z power minus N. Okay, so it is entirely valid for the discrete signal. It is valid for the discrete time signal. Okay, so now find the Z transform of the following sequences or signal. So first one, what comes to your mind? The first problem, what I'm giving you right now is X of N, N times A power N U of N. Okay, so N times A power N U of N. Okay, so now to arrive at the Z transform of this signal, say X of N, that is X of Z, that is there. So that is the Z transform of this signal. So X of N, which leads to X of Z, that is entirely an algebraic expression expressed in terms of Z there, right? So now let me proceed how to solve this problem here. Okay, so now I know that N is present, it is multiplication by RAM, and I have A power N U of N as the signal which is present there. So X of N, the signal which is N multiplied with A power N U of N. So you have to understand the signal what is there here, that is N into A power N U of N. So we look at the standard identity, right? So Z transform of A power N U of N. So can anyone let me know it is a left-handed sequence or a right-handed sequence or a double-sided sequence? Anyone can unmute and they can let me know whether this signal A power N U of N is a right-handed sequence or a left-handed sequence or a double-sided sequence. I had recorded and posted a few videos related to Z transform. I think depending on that, you can understand and you can let me know whether it is a right-handed sequence or a left-handed sequence. Yes, class? Yes? Can anyone let me know?
It's a right-hand sequence, sir.
Yes, exactly, Vinod. That is right. This would be a right-handed sequence. How did you tell that it is a right-handed sequence? I want the session to be interactive so that we can discuss where you guys are going wrong and where we can correct ourselves and solve it quickly. Okay. Yes. So can you let me know how it is called as a right-handed sequence? Yes, you are absolutely correct. We know this correct. And how did you come to know that A power N U of N, the signal, is a right-handed sequence? Okay. So let me tell you. Now you have U of N here, A power N U of N. So the summation would be from N is equal to 0 to infinity. So once I have the summation from N is equal to 0 to infinity, I can say that it is a right-handed sequence. Right-handed sequence. Okay. So I have Z divided by Z minus A. That is the Z transform of A power N U of N, which is called as a positive time sequence. Now, N is multiplied here. So in order to arrive at X of Z, that would be equal to Z transform of X of N. That is nothing but z transform of n times a power n u of n. So what do I need to do? Any signal which is multiplied by n. So its z transform will be minus z multiplied with d by dz of x of z. Okay, so it is minus z into d by dz of x of z. So how I can generally write down this equation as minus z? So I need to take the differential operator of the given x of z. Okay, so this one here, which will give me the differential operator. So this is what I need to differentiate here. So that is d by dz of z divided by z minus a. So this is what I need to do here. So hope you have understood what I'm doing right now. So I have a ramp function. So for a ramp function, from the property of the z transform, I can write it as minus z multiplied with d by dz of x of z. Okay. So next what I can do here is minus z multiplied with d by dz, that is z minus a the whole square into z minus a into 1 minus z into z minus a. If you differentiate it, so it is u by v what you are differentiating. So hope you know the basics of differentiation, and this is what we get by differentiating two terms which are there as a fraction, right? So minus z, okay, minus z and plus z get cancelled. So at the end, I have az divided by z minus a the whole square. So this is nothing but the z transform of n a power n u of n. Okay, so very important identity once when you come across any signal which is there. Okay, so in your gate or any competitive exams, you will be having to ask, like they will be asking the direct one where you can have such things directly being written there, right? So n into a power n u of n, that would be equal to the z transform of it will be equal to az divided by z minus a the whole squared. Okay, moving on to the next problem, it is quite easy. What you can do is you can have x power x of n, that would be equal to n times a power n minus 1 into u of n. Okay, so I'll be giving such problems to you people. You can just do it. I can name any one of them and they can do it. Okay, so next one would be a n plus 1, n times a power n plus 1 into u of n. Okay, I think this problem Vismaya can solve it. Vismaya can solve it, and this one I think Hemant will be able to solve it. Hemant Hechi. Okay, so here Vismaya and Hemant, so they can solve these problems. That is the second and the third problem. So keep a reference of the problem that we had done here, and later you can proceed with the problem number 2 and problem number 3. Okay, so you can able to do it, and you can submit the answers by today within 8 p.m. So next what we have here is we can have the impulse sequence, that is h of n, right? So a problem like this, which is repeatedly asked, use the z transform, use the z transform to perform convolution, of the following sequences, of the following sequences. Okay, following two sequences. Let me be precise. Following two sequences. That is h of n, that would be equal to 1 by 2 power n 0. Okay, and 0 it is elsewhere. Yeah, it's elsewhere. Okay, yeah. Fine. So this is the sequence of x of n. Now h of n would be delta n plus delta n minus 1 plus 4 times delta n minus 2. Okay. So now what do I need to do? I need to perform the z transform for the given signal, that is given two sequences, that is h of n and x of n. Okay. So now y of n is the convolution of two signals, that is x of n convoluted with h of n. So what do I have here in order to get the z transform of it? I have y of z that would be equal to x of z multiplied with h of z. Y of z that would be equal to x of z multiplied with h of z. Fine. So now what I can do here is I need to find out x of z plus, I mean, first thing, what do I need to do? I need to find out x of z. Next, what do I need to do? I need to find out h of z. Okay. So look at the sequence here, that is h of n, that is 1 by 2 power n from 0 to 2. So let me write down the sequence here, that is h of n, that would be 1 by 2 power n, half power n, that is 0.5 power n. So it would be from n, which is from 0 to 2, okay, and 0 elsewhere, okay, 0 elsewhere. So what do I need to do here? So I need to have h of z being written. So h of z, if I want to write it, what I do, z transform of h of n, if I want to write, so that would be from sigma n is equal to 0 to 2. It would be a finite sequence here. Okay, I repeat, it is a finite sequence. It is not an infinite sequence. It is a finite sequence because the length will be from 0, 1, 2. Okay, only 3 samples we have taken, and it is x of n multiplied with z power minus n. Okay, so 0 to 2. I can cut down the summation depending on the sequence what they have mentioned in the problem, that is from n is equal to 0 to 2. Okay, so now what I do here is, so sigma n is equal to 0 to 2, 1 by 2 power n, z power minus n. Okay, so let me keep on with the values, that is 1 z power 0 plus 1 by 2 power 1 z power minus 1 plus the next one 1 by 2 power 2, okay, z power minus 2. So this is 1 plus 1 by 2, 0.5 z power minus 1 plus 0.25 z power minus 2. Okay, so this is h of z. Okay, this is h of z, what I have here. So I have h of z like this. Okay, very important thing what I'm mentioning here. So this would be the base for the next type of problems that we are going to discuss in inverse z transform. So where in inverse z transform, I'll be talking about directly from h of z, I can write h of n. So such sequence are to be repeated quite again and again. Okay, so now I have got h of z here. So my next step would be to find out what is x of n, that is already given in the problem, and from x of n I need to find out x of z. Okay, so that's what I'll be going to do here. So in x of z, if I want to find out, I need to look at the sequence of x of n. So that is delta of n plus delta of n minus 1 plus 4 times delta of n minus 2. Okay, so now delta n, okay, so what is the z transform of delta n? That is 1 plus what is the z transform of delta of n minus 1 and delta of n minus 2? Can anyone let me know? Yes.
Z power minus 1 plus 4 Z power minus 2.
Very good. 4 power z power minus 2. Okay. So you know the sequence, z transform of delta of n. Okay. And z transform of delta n minus n naught. Okay. So that is z power minus n naught is there. So in place of n naught, I have 1. In place of n naught, which is the third signal here, that is n is equal to 2. Okay. So now x of n is being present. X of z would be z transform of x of n, and it is 1 plus z inverse plus 4 times z power minus 2. Okay, that is x of z here, right? So that is x of z. So I have h of z also being written. Let me recall what I did for h of z. So z transform of h of n, that would be equal to 1 plus, yeah, so 1 plus 0.5 z inverse plus 0.25 z power minus 2. Okay, I have h of z and x of z being written here. So what do I need to do in the next step? So I have y of z that would be equal to x of z multiplied with h of z. Okay, so this is what I have here. So x of z, I'll be replacing it, and h of z is also being replaced here. So what do I do here? I just write it down and I will leave the multiplication part to you, where you will be able to solve it and you can able to get me the answers quite quickly. And if you multiply these two sequences, what you will be getting there at the end is, we'll be having 1 plus 3 by 2 z inverse plus 19 by 4 z power minus 2, okay, plus 9 by 4 z power minus 3, okay, plus z power minus 4. So if you take these two sequences, if you multiply them, you'll be getting 4 into 1 by 4, okay. So you'll be left out with z power minus 4 at the end. So this is y of z. Okay, this is y of z. So what do I have in the next one is taking the inverse transform of it. Okay, so I need to find out a h of n. So z transform of it is fine. That is finding out y of z. But the given sequence is in terms of h of n and x of n. So it is entirely in time domain. That's the reason taking the inverse z transform of it. Inverse z transform. Inverse z transform of it. Okay. So now I have y of z being written as 1 plus 3 by 2 z power minus 1 plus 19 by 4 z power minus 2, okay, plus 9 by 4 z power minus 3 plus z power minus 4. Okay, so now what we did for x of n, if you can recall, I hope you would not do certain problems here. So I think there was a network connectivity issues from one of your side. So see to it that you don't repeat it from here onwards. So taking the inverse z transform of it, if you can recall what we done in x of n. So from delta of n, we found out z power minus n, like delta of n minus n naught, that would lead to z power minus n naught there. So here, in a similar way, we are going to back work it, right? So I have y of z here. I need to find out y of n. So if I want to take the inverse z transform of each and every term here, we can do it as delta of n for 1. Okay, taking the inverse z transform. Let me write the constant as 3 by 2. Delta of n minus 1. Okay, plus 19 by 4 delta of n minus 2 plus 9 by 4 delta of n minus 3 plus delta of n minus 4. So that is y of n. Okay, so that is y of n. So this is the output of signal. Okay, output of signal when convoluted, when convoluted, when convoluted with x of n and h of n. Output of the signal when convoluted with x of n and h of n. So what do I get here? I get y of z, okay, which is there. So y of z is being present. From y of z, what do I get? Y of n would be equal to 1. The inverse z transform of it is delta n, and z power minus 1 multiplied with 3 by 2, that is 3 by 2 delta of n minus 1, and so on. So if you can observe very carefully the y of z, that is the term which is being present there, so you can easily find out y of n. So it is just like back working. Okay, so hope you have to solve a few more problems related to it to get a better understanding of the taking inverse z transform and taking the z transform and applying what are the properties that are there in the related z transform approach. Okay, so let's move on to the next one, which is inverse z transform. Inverse z transforms. Inverse z transforms. Okay, So in inverse Z transforms, what we are going to do is by partial fraction method. So we are going to have the partial fraction method, okay. So inverse Z transforms. So from Z transforms, we are going to find out the inverse Z transform by first method, that is by partial fraction method there, okay. So now what we can generally understand by the partial fraction method is, so I have a signal that is x of n, okay. So I have a signal that is x of n, and its Z transform is given there as the algebraic expression there. So it is a rational function of Z. Rational function, rational function of Z. Okay. So now it is a ratio in which you can express. So ratio of polynomials there at the numerator and the ratio which is there at the denominator end there, right? So what you can do is you can find out x of n from x of z. Okay. So now you can generally notice in any of the given problems, you need to take it as x of z divided by z. Okay, on one end, you can have the x of z by z. So just because the partial fraction expansion is being performed by taking x of z by z there. So if it appears in one of the numerator term, you can take it as a common factor and you can divide it with the left hand side term which is there. So this expansion is obtained, and later on, after finding out the constants by multiplying the partial fractions, you can let us know how this z can be multiplied again to the constant terms, to both the constant terms which are being present, and you can come to a conclusion to find out the x of n signal. Okay, so now the expansion term can be obtained at the end by multiplying z to find out the original expression there. So first what we have to do, we have to take the rational function there. Okay, so next one you will be having the second function which is x of z by z. So third one you are going to have the partial fraction method. So I'm writing it as PF, it means partial fraction method. So next what you are going to do, this x of z by z, as k2 divided by z minus 4. Okay, so this z is being multiplied to both the terms here. So z divided by z minus 3 plus z divided by z minus 4. So this is x of z here. Okay, so now the fifth expression what I have here to take the inverse transform of it. So these are the 5 steps that are generally involved in obtaining the inverse z transform of the x of z signal. Okay, so now let me proceed with the given problem. Simple problem. You can have this simple problem also being many problems, like this is one which I found to be simple there. Okay, so 3z squared minus 4z plus 1. Okay, so now what do I need to do? I need to take whether it is in a rational function of z here. So this is z power 1 and z power 2. So I have this power of z, okay, so which is less. So numerator, let me take it as m, the power of polynomial which is expressed in z, it is less than n. Okay, so this is the term which is present there in the denominator, polynomial, right? So this is a polynomial in the denominator, that is 3z squared minus 4z plus 1, and the numerator one is z here. Okay, so I have m less than n. So what is the next step here? I have x of z by z. So one more thing which I wanted to highlight here is, so if both the expressions are equal, okay, so what needs to be done is you need to perform and you have to come to a conclusion where such expression is reduced to m less than n. So you have one more term there. Okay, so you need to perform the long division method to obtain such terms here. So you might have the long division method also being done. You know it better. I'll discuss few more problems regarding that so that it would be quite easy to understand. Okay, so assuming that you know a bit of partial fraction method, so let me not go in detail to it. So here I have z power 1, x of z by z, 1 divided by 3z squared minus 4z plus 1. Okay, so now I have this like expression as 1 divided by 3z squared minus 4z plus 1. So what I can do here is I need to take 3 as the common factor. So it would be easy for me to perform. So this is 3 which is there. So z squared minus 4 by 3z plus 1 by 3. Okay, so I need to evaluate this function. Okay, so to find out the roots of it. So what do I do? One third of it. Okay, so 1 by 3 I can write it like this. So what do I do here? Z squared minus 4 by 3z plus 1 by 3. Okay, so what do I do? I take x of z. Okay, x of z divided by z, that would be equal to 1/3 divided by, what do I do here? I'll be having z squared minus 4 by 3z plus 1 by 3. Okay, so this is the expression what it is being reduced. So now if I want to have this expression being reduced again, so I need to find the roots of it. So z minus, okay, what do I do? Minus 1 by 3 times z minus 1 by, yeah, 1 by 3 and 1. Okay, so I have 1 by 3 here in the numerator. So how do I expand this? I expand it by partial fraction method, such as a divided by z minus 1 by 3 plus b divided by z minus 1. Okay, so what do I do next? A times z minus 1 plus b times z minus 1 by 3. Okay, so I have this expression, and at this end I'll be having 1 by 3. So you know that both the terms get cancelled and you are left out with this expression here. Okay, so how do I find out the constants? Finding out constants a and b. Finding out constants a and b. So how do you find out constants a and b? In order to find out constants a and b, so this term must be equal to 0. That is, z minus 1 by 3 should be equal to 0. A would be equal to 1/3 divided by z minus 1, where z would be equal to 1 by 3. Okay, so this is how I do it, and I'll be evaluating a, right? So 1 by 3 minus 1, that is 1/3 multiplied with 3 by 2. Okay, so a would be equal to 0.5. Okay, so the value of a here is 0.5. Next, what do? I need to find out b, right? So b would be equal to 1/3 divided by, this is z minus 1 by 3. Okay, that would be where z will be equal to 1. Okay, 1 minus 1 by 3. What is the function here? I think a is minus 0.5. If I'm yeah, minus 0.5. So this is 1 by 3 minus 1. So we'll be having minus 2 by 3. So it is minus 0.5. Okay, minus 0.5. Okay, so z equals 1 here. So 1 minus 1 by 3. What will be the reason? That is 2 by 3. What will be the answer? That is 2 by 3. So you will be having b as 0.5. Okay, so I have a and b as minus 0.5 and b as plus 0.5. So what do I do here is I have x of z. So this entire term is reduced as a partial fraction method. So this is partial fraction method. This is the partial fraction method here. So this partial fraction method, if I want to reduce, so what do I get? I have x of z by z. I have a as minus 0.5 divided by z minus 1/3 plus b as 0.5 divided by z minus 1. Okay, so what do I do in the next one? I have x of z divided x of z, that would be equal to minus 1 by 2 z divided by, what is the expression that I have here? So that is z minus 1 by 3 plus the next expression, that is positive half z. Okay, 1 by 2, I will be having z divided by z minus 1. Okay, so now if you can look at this equation quite clearly, what do I need to do? Okay, so I need to perform the inverse z transform. In addition to it, so you have to find out the inverse Z transform for the following ROCs. For the they would have mentioned this one for the following ROCs. That is mod Z greater than 1. Okay, for mod Z greater than 1, I think yeah. So for mod Z greater than 1, next one, that is mod Z less than 1/3, and third one, which is mod Z, where it is a annular region between 1 to 1/3. Okay, so looking at this ROCs only, you can find out what are the roots of the equation. Okay, so the ROCs mentioned are, I'll take another 10 minutes. The ROCs mentioned are mod Z, which is greater than 1. So for ROC which is having mod Z greater than 1, so what do I need to do? I need to have it as a right-handed sequence. Right-handed sequence. Okay, completely I have it as a right-handed sequence here. So if for mod Z greater than 1, what do I need to do? I have x of z term which is present here. So for this x of z term which is present, so I need to find out x of n. Okay, so I need to find out x of n. So for x of z which is present, I need to find out what is x of n for the first ROC, that is mod z greater than 1. Okay, so x of n would be given as, right? So I have these two terms which I need to express. So mod z greater than 1. So let me sketch the ROC here. So if I want to find out ROC, what do? I have the y-axis here and the x-axis here. Okay, so what are the roots here? So 1 and 1/3. So roots of the denominator of the expression is called as the poles. Okay, very important one, POLES. So these are the poles here. So poles, I can write it here and you can express it. So 1/3 and this is 1 here. Okay, so mod z greater than 1. So ROC here will be away like this. Okay, it is an entire z plane. So this is also 1/3 is greater. Okay, so after it crosses, it reaches 1 and the entire z plane is greater than 1 there, right? So x of n, if I want to find out what is x of n, this is 1/3 and this is 1 and this is the origin here. So the entire z plane except at z is equal to 1/3 and z is equal to 1. So the ROC would be greater than 1 here. So mod z would be greater than 1. So how to find out x of n? So x of n would be equal to a completely right-handed sequence, and you can have the ROCs will give you x of n to be a positive time sequence. So 1/2 is a constant and minus 1/2 is also a constant, minus 0.5. So how you can write the inverse z transform of z divided by z minus 1/3? How you can write it? So that is 1/3 power n u of n plus 0.5. Okay, so z divided by z minus 1, that is 1 power n u of n. Okay, so I have it as minus 0.5 1/3 power n u of n plus 0.5 1 power n u of n. Okay, so you can leave 1 power n, it is 1 itself. I can have 0.5 with a negative sign minus 0.5 1/3 power n u of n plus 0.5 u of n. Okay, so that is x of n signal for a given sequence, that is mod z greater than 1. Okay, so for mod z greater than 1, what do I have here? I have this function which is written from x of z to x of n. So similarly, you can write it for the second sequence where you will be having mod z less than 1/3. Okay, you can make an attempt, and the third one, what you can get is, so for mod z less than 1 and 1/3. Okay, so this would be the annular region. I'm giving you a hint. This would be the annular region. Okay, and next one, here you will be having the negative time sequence. Okay, both the signals will have negative sequence, negative time sequence, negative time sequence, and this one you will be having one positive sequence. One is the positive time sequence, and the second one will be the negative time sequence. I want everyone to attempt this negative time sequence. Okay, so the second one will be a positive negative time sequence, and here you will be having both positive sequence and negative sequence together. Okay, so with this one, okay, so you have to find out like for a given ROC what is x of n, okay, for the second one, and this here for the third one also you have to find out x of n from the given x of z here. Okay, and yeah, 1 minute. Yes, and hope this lecture was quite useful to you, and let me stop recording. Okay, and meanwhile you can reach out to me anytime, and we can have our discussion any day. Okay, so see to it that you have to work, and I'll be sending you the related study books where you can study it, and if you have any doubts you can reach out to me. Okay.